Right, we are looking at 7.5, which is factoring the GCF from polynomials. Well, we got to remember, first of all, G factor. And you worked with those a while back, I don't know, 5th grade, 6th grade. So greatest common factor, so it's down here, I'm not going to rewrite it, but greatest common factor, so the GCF, and what we call factoring. Basically, what that does, what factoring is undoing the distributive property. You're just going backwards. All factoring is undoing the distributive property. So for example, if we had this, if we had 3 times 3x plus 2, we would distribute and get 9x plus 6. Well, factoring is now we're pulling out common factors between the two terms. Okay, so factoring is undoing. Now, this is very similar to what you just did last section with dividing polynomials. So really that's what you're doing is you're finding a number that goes into both of them and dividing each of those terms. So this is undoing. So we're like, okay, 3 goes into both. Well, 3 goes into both. So that would be 3x plus 2. So it's undoing the distributive property. That's what it's doing. It's undoing the distributive property. Now, simplest form means it is written out. So for example, this one, 4a squared plus 8a. That's combined, it's ready to go. Factored form is when you pull out the common factors, not only of the numbers, but also the variables. Now, what number goes into 4 and 8? Well, that's 4. What number? This is a squared and a. Now, I'll go down here and teach it more. But a squared plus 8a, well, there's 2 a's in an a in each of those. So you're really saying 4a squared plus 8a, you're really dividing 4a into both of those. So then you have left is just an a plus 2. So what you're doing, this factors out, this is an a, and then 8 divided by 4 is 2, but the a's cancels. So dividing exponents, remember you subtract the exponents. If a polynomial cannot be factored, it is called prime, meaning there's nothing in common. You have nothing in common with those. So let's just do a little review on greatest common factor of each set. The 16 and 8, or 24. 16 and 24. The greatest common factor, those are the numbers that go into it. So remember, factors are the numbers that multiply. So 16 is 1, 2, 4, 8, 16. 24, there's a lot of them. 1, 2, 3. I got to do it this way. 1, 2, 3, 4, 6, 8, 12, 24. Greatest common factor, what do they have in, not 6, but 8. So the greatest common factor is 8. So the largest number that goes into both of them. This one, 15 and 30 is 15. 6, 12, and 15. Well, what's the largest number that goes into all 3 of them is 3. 12, 15, and 24 is also 3. Sometimes you might have to list them out, the factors, to find it. Okay? Now, we're going to find the GCF of a set of monomials. So the monomials, identify the GCF of the coefficients, the numbers, then look at the variables. And we're going to see how many of the variables they have in common. All right, so let's look at the GCF of the coefficient, 7 and 14. Well, the greatest number that goes into both of them is 7. Now, the common variables. Okay, let's look at the variables. They have a squared, b cubed, a, and b to the 5th. Now, how many total a's do they have in common? This has 1, that has 2. So only 1 a in common. How many b's? This is 3 b's, this is 5 b's. So they have b cubed together, it'd be 7a. That would be the GCF of both of those. Okay, and that's what we would divide by. Okay, let's look at 3 and 6. Well, 3, now look at the x's. That has 2 x's, that has 1. So this is only going to be 1x. So 3x would be your GCF of these two monomials. This is a monomial. Remember, it's one term. There's no plus or minus in between them. Okay, now 4 and 5. All right. The GCF of those coefficients is just 1. Don't put 0. It's really 1, but you won't really need that. Oh, this is an a squared, b cubed, c, and d. There's nothing in common here. So that, oh, I better not put an x. Whoops, oops, oops. There's no common. There's really, that's prime. They can't be factored. So that's prime or just 1, which is no need to divide by 1. So these, you can say prime, meaning there's no GCF in there. Okay, 5, 6, 7 will be 1 in order, right by each other. There's no common factor. And if there's 3 terms, they have to be a common number in all 3. Okay, I don't remember if I told you guys, but relatively prime. That means that's relatively prime numbers there. Okay, let's look at the x's. X cubed, x squared. Well, the lower exponent, so there's only one x in common. The y's, y squared, y4. Okay, y squared. That has 2, that has 4, that has 5. This is a z, but the rest of them don't have a z. Those two have a w, but not this one. So you can't put a letter in if it's not in all 3 of them. Okay, so this one is just going to be really xy squared. You really don't need that 1. You divide by that. Okay, now 16, 28, and 8. Okay, they're all even, 2, but let's see if there's a larger number. 4, 4. So always get the largest number that goes into it. Okay, x, no x. Y squared, y. So just y. So we're looking at 4y. So now we're going to work with these to divide. Okay, but trying to find the GCF. So we're factoring out the GCF. So check the coefficients first, and then look at the variables. Now, notice this, 3x plus 12. We're undoing the distributive property. Okay, so what's the common number is 3. So think about this. If you divide each by 3, think about dividing the polynomial. Divide by 3, you get x plus 4. Now, if you're not for sure, check it by distributing. 3, okay, so recheck it. Maybe I'll change my pen. Check it. 3x plus 12. Good. These two should match. Okay, so then I know that's correct. All right, 8m, oh, and 36n. So 8 doesn't go into 36, but 4 goes into both. So I'm going to do 4, 8m divided by 4 is 2m, plus, now there's no letter that goes into both of these. Okay, so 36 divided by 4 is 9. It's 9. I'm making sure. Now, also check, because if you don't pull the GCF out, if you can still divide here, I was just checking on that to make sure. But you cannot, you can't divide here anymore, so you're good there. 6a squared plus 27. 6 and 27. 6 cannot go into 27, but 3 does. So I'm going to divide each by 3. So I get 2a squared plus 9. Okay. All right, now be careful here. Now we have some that have the variables. 4, so 4 goes into it, and the y. So we have 4y, 4y, so 4y. Now, you can go through and check. That would be a good thing to do. I'm just trying to save some time here. Now, this is going to be a y left. Be careful your negative. Negative 6, or y minus 6. So this is going to be 4y. You're undoing, you're pulling out a common GCF of both. Okay? Now, 3 goes into both. Notice, though, there's a D and there's a D. So 3D, 7, so it's going to be 7C. Now, be careful here. Negative 3D divided by 3D is a negative 1. Don't put 0. That's the most, be careful, be careful, be careful. That's the most common mistake. 0 instead of dividing. Don't add these, divide. Okay, so, oh, there's an A, there's an A. Now watch, be careful here. We're going to take out an A. We're going to have B minus 1. Whenever you factor, if you have two terms, you should still have two terms at the end. Now we have three terms. We should still have three terms at the end. All right. What's the common factor in 6, 14, and 10? That is a 2. And look at your y's. We have a y squared, nice, all of these. So you're going to divide everything by 2y squared. So 2y squared. Put that outside. 6 divided by 2 is 3. Y to the second, because you're going to subtract. Plus 7y, watch your sign, minus 5. Now, if you're not for sure, distribute. Now, when you distribute, remember you add the exponents. So 6y to the fourth plus 14y cubed minus 10y squared. Yes. Okay. So check it by redistributing. All right. This one looks crazy, but just take it one step at a time. Look at the numbers first. Well, there's a 3. I can do 3. Now look at your a terms. A is the only amount that I can take out. B. Oh man, this is a crazy one. B squared. C. C. Whoa. Okay. So I'm going to take out a 3ab squared c. Whoa. Okay. So the 3's cancel. A squared. I think I have a squared left. Then negative 3a b squared, b cubed, b squared. I have a b left. And I have a c left. 3abc, I think. Then plus 5, no a's, b squared, and c squared. Whew, that's a crazy one. Okay, so that's what you're doing. All it is factoring out. You're undoing the distributive property. Now, if you want to go through and check that one, you go right ahead. But the biggest concern is this. Do not, when you get everything gone, make sure it's a 1. Don't put 0. Okay, so that is 7, 5.